This course is followed by another course which is named Applied Programming, where the focus is how to teach programming. The target group is teachers who teach in grades 8 to 13, that's secondary school, but is open for all teachers in K-12. We conducted a pre-course survey to figure out what different levels and subjects the teachers are teaching. We received 186 responses, which is a rate of 93%, and approximately 80% say that they are teaching at upper secondary school, and 20% teach at lower secondary school. And more than 80% of the teachers are teaching STEM-related subjects. Others teaching different topics, such as language, history, music, etc. And we also know that 61% of participants had some level of programming knowledge before starting the first course. And 24% of participants have already taught programming in their schools. The participants all come from the same country, but they represent various schools and districts. All schools follow the national curriculum, and participants differ in terms of the subject they teach, school type, and motivational factors. Therefore, the study covers different perspectives. We use the method thematic analysis to analyze our qualitative data. Teachers start the second course, which is the applied programming, by reflecting over questions such as, why should everyone learn to code? What are the obstacles, challenges, and or motivational factors? We collect reflection notes. We have collected reflection notes from 2019 and 2020 cohorts, and analyzed a total of 328 reflection notes. For 2019, there were 22 out of 17 notes available for data analysis, and for 2020, 169 out of 170 was used at the start, and 137 at the end of the course. So as we have marked on this in this figure, these are the start and at the end, but most of the reflection notes are from the beginning of the course, where teachers reflect on these questions. To ensure high validity, we used a significant sample size, which is 328 reflection notes for this study. And teachers reflected without being directed by any questioner. A limitation is that most participants may already be aware of the benefits and importance of learning programming. And another limitation is that the results are mainly from one course, and it might be not be easy to generalize the results. In this table, we see that many teachers, that's 233, agree to include programming in school. And we find a total of 277 references. We find many teachers talking positively about including programming in school, as we can see here. But there are also teachers saying that programming should not be included for all in schools. And we find few teachers who seem to be critical to do so. However, these data indicate a change in attitude towards end of the course for the 2020 cohort. Teachers come up with different arguments for why everyone should learn to program. So some examples are a tool that helps better understand other subjects, abstract thinking capabilities, interesting, fun, and engaging, etc. And we can see that what concerns teachers mostly is the use of programming as a tool to better understanding other subjects. So if they teach STEM-related subjects like math, science, then they would like to use mostly programming as a tool to get a deeper understanding of those subjects. Teachers also say that programming can invoke joy, enthusiasm, curiosity, and be fun. But at the same time, they say that it's a time-consuming process, and therefore pupils, they argue that pupils must start as early as possible to learn programming. Some teachers are critical towards programming in school. The main argument for this group is related to lack of time and motivation for doing so. So let us briefly review some of our findings. Our study results indicate that in-service teachers are positive towards programming for all, even though it is challenging and difficult to achieve. Teachers in this context are most concerned with using programming as a tool, as I mentioned earlier. Abstract thinking capability is another area that concerns highly in-service teachers in this study. And many in-service teachers argue that programming is one of the most crucial job skills in the future. It is a time-consuming process. Therefore, pupils must start learning to program early. And several teachers express that programming may even out differences in the population. Everyone will have the same opportunity regardless of social background and gender. In-service teachers also express skepticism about introducing programming as part of other subjects, which may go beyond their allocated time. These concerns are mainly related to lack of time. Having enough time to teach students how to program and using it as a tool for developing other skills is highly important. The decline in the number of in-service teachers being critical to programming for all may indicate a change in their attitudes during the course. So in this study, we looked into the preliminary results on how in-service teachers conceive and interpret programming for all, and why programming should or should not be included in school curricula. Most of the in-service teachers in this study believe that programming can be fun and engaging. They come up with many arguments and reasoning for why they should include programming in schools. This study suggests that in-service teachers may be concerned with using programming as a tool in the subjects that they teach. This way, they may increase learning outcomes in subjects where programming is applied. At the same time, they express skepticism about introducing programming because this may the time may be a challenge. So our main contribution in this work is that our data indicates a clear positive evolution of the in-service teachers' perceptions towards the dissemination of coding and programming in school curricula. And for the future, our researchers need to investigate further how programming is taught to this group at other institutions compared to the one we do at our university. And studies across countries would be relevant to understanding how the educational system and other programming courses impact teachers' attitudes. Thank you for your attention. So I'm ready if you have any questions.
So thank you very much. So if any, there are some questions. So any question for Majid? So please, you can both writing on the chat or raising the hand.
May I?
Okay, so
yeah. Thanks for the talk. I'm a comment on this. I had always some doubt about the need to teach code to everyone in the school. I mean, this is a topic that is very popular now in Italy because everyone is talking, for example, about the coding hour, etc. I wonder if it would not. I'm very convinced that, for example, that one should teach to everyone object-oriented thinking, but not object-oriented programming. So, for example, I'm very convinced that one should learn to use a UML. And I'm wondering if it was not better to teach to young generation the meta programming. So using, for example, diagram or so on rather than coding. Because this, for example, could be included also in other discipline. You could use meta programming in all the discipline without affecting the time that is that has been allocated for those disciplines. Could you comment about?
I think it is a very interesting point you are mentioning. But what we have experienced by running these courses, we have now, this is now the third year we are running these programming courses. We started by 100 teachers, and now we are approximately 300 teachers in this course. And what we hear a lot is that they have the issue with the time, where they do not have time to spend too much on the programming concepts, on areas, concept which is not directly relevant to these guys. So it seems that what they want to know is exactly those concepts which they can use to, as I mentioned, use the programming as a tool to try to kind of resolve the issues within mathematics or other things. So I think it's very interesting what you mentioned, but the question is then how far it is, or the distance between learning the object-oriented concepts to where they actually can start resolving programming or coding or using programming to resolve their different tasks or problems within their subjects. Because what we can understand is that they want to use programming only, mostly to get some benefits in the subjects they teach. So if they don't get these benefits, then probably they are not that willing or interested to spend their times on this. So, but it's we haven't done. We do have actually object-oriented as part of these courses, only just to touch the concepts and tell them a little bit, but the time is an issue. So I don't have a clear answer to your question.
So there isn't one, I think. So there is a one. So right now, so the Carlo suggestion is a sort of an interesting points to discuss together. Also, if you want after this session. So the time is over. So unfortunately, and we can still go ahead. So, but thank you, Carlo, and thank you, Majid, for your presentation. So for your results.